Okay, morning, man. I'd like to share our research on Swarm AI GC agent-based approach for shale oil wellbore operation decision support with their field implementation in Western China. I'm Chen, coming from CNPC. This is the content for today's presentation. Begins with a background for wellbore downhole operation in Western China, followed by the current mode and restrictions of wellbore maintenance. Our proposed approach to deal with the issues remained will be discussed in section 3. Experimental results, discussions, and concluding remarks of the future prospects will be delivered in section 5 and section 4 and section 5 respectively. We all know that shale oil plays an important role in energy supply and consumption of China. This makes the wellbore downhole operation even tightly in order to meet the quality and products requirement. As the statistics acquired from one of major China's shale oil provider in terms of the time spent of a wellbore downhole operation, the scheduled inspection dominated most of the time, reached 82%. This classical maintenance and planning model cost budget and make the maintenance strategy a couple of redundancy. Since even reliable wellbore performed at this moment, the rare failures happened suddenly, might cost more amputees. This driven quite a set of restrictions, and through the daily operation side, we got fragmented for the response increase the amputee inconsistency between centralized decision and distributed execution as a variety of teams to execute various tasks. So inconsistency happened is quite obvious. Now, the decision making in terms of complex wellbore operation strongly rely on experts' experiences, and they now like to do this manually. Apparently, low efficiency here. To look through the restrictions from goal achieving side, we see that we're facing varieties of abnormals and data modalities. The decision making, as mentioned previously, strongly relies on experts and experiences. And another key important thing is we now lack of prior to failure data, i.e., the intermediate data to describe the progressing of wellbore conditions from health to failure. This makes it difficult to trigger. These all issues makes it difficult to trigger refinable and autonomous workflow to empower our wellbore operation efficiency. Now, let's take a look at our demands of wellbore maintenance. The event trigger instead planned cover multiple abnormals. The expert knowledge embedded for precise scheduling is also needed. The intermediate evolution process from the latent data space to describe the progressing of our wellbore condition developing a clue to schedule clue is another important thing, and it's quite necessary to form the autonomous processing and to form the self-refinery in the era of generative AI. The business financial integrated operation and calculation is now necessary to be taken into account for revenue max, and the efficiency max is used to find the global optimal. Based on the previous demands, we now using our agent neural-based architecture we designed first to form the intermediate evolution in the latent space. We got as the simple mathematical expression demonstrated here. Classically, we got health, failure, and just two extremes. And for now, we got health, intermediate state, and failure. We got the progressing through here. It's a agent neural-like architecture. So once we got the remove and revise information flow here, we've been able to simulate the progressing and eliminate non-use states and keep the potential possibility of developing a clue to the next phase. So we got a set of assumptions regarding to the current situation of wellbore conditions and the potential development clue to failure based on various ways. So we've been able to simulate it and make our prior to failure decision early. So based on this intermediate our latent-based space, now we start to form our swarm agent-based architecture here. We've got multi-role mixture of expert system for the whole workflow with each sub-agent got their sub-skills included. The main skills of this SAA system include the issue spotting, work decomposition plus planning, autonomous execution through deep understanding, which is the basic abilities formed by the fundamental generative AI model, and the concluding feedback, continuous feedback to form the self-refinery, which is the key demanding of the shale oils end user. And once we apply our SAA to the wellbore operation process by embedding our swarm agent to the whole process, one agent assigned to one subtask here, including the tool using content generation and workflow orchestration abilities assigned to various agent roles. Now, we've been able to achieve our event-driven wellbore maintenance workflow divided here. And the abnormal could be used as the main trigger to form the whole process. And we boosted our hidden space operation to dry run the wellbore deteriorations and find out the potential refinery crew. The financial, economic, and knowledge accumulated decision making is now triggered in order to provide an optimism outcome here. So once we got this SAA embedded into the wellbore operation process, now we got the main workflow of the SAA approach need to be introduced here. The first of the SAA formation step is the role declaration. It's important to nominate your agents to various roles, identify problems among the whole process, and determine refinery workflow in order to form the agent's system as a closed loop. Then these swarm agents can be used to start their task understanding, to complete the tasks by agent recruited, and to find their objective scopes, constraints, or in an autonomous way. The sorter analysis is now assigned to their certain tasks system, and the prospect output will be defined too. Then the agent role allocation are now triggered to compose sub-agents by step 1 to step 2 and into the certain process. In this study, the wellbore process, then the swarm agents gonna start their thought chain organization, including the question review, question refinery, and the insight ranking. Now, the first 4 steps are determine the agent developing criterion, and these 4 are for execution. We got task decomposition to decompose the subtasks and make our agents pay certain attention to spot the key value. The knowledge contributions and the knowledge attribute need to be understood, and the priority pickup, break down the workflow to form the workflow, and determine initial feedback by prompting. Then the execution process includes the understand to-dos and the decompose to-dos in achievable steps, and to nominate possible tool use if needed. The traceback and debugging will be determined eventually in this step. The task execution 2, the second main part is to determine the orchestration policy, to determine the autonomous process execution as well, and to make the continuous refinery started. This is going to form the final optimal workflow here. And another key important thing is the feedback optimization. Assessing the result to assign a certain agent for assessing the result to improve the workflow and to remove the duplicated things, update new and report the next iteration in order to form the closed loop and keep these agent swarm agent clusters, keep them growing. Then here's the experimental setup here. We now verify our performance regarding to this SAA with this simulation aided. The historian data, including wellbore maintenance logs from 2020 to 2024, were used for training. The situations, including normal, pump leakage, rod fracture, wax decomposition, are used as the starting objects. Knowledge corpus picked up from the public website, from the United System CNPC, and from the historian accumulated by the experts were used as a knowledge database to make the decision explainable. Then we recruited 15 experienced volunteers, including 10 engineering side and another 5 from financial side, to create wellbore situations they've been through and provided reference answers as well. The SAA approach is used after training. Is used to find objective answers through the latent space. The cosine similarity between reference answer and the generated were compared by using upon 3 different foundation models. And this cosine similarity is used to verify our approach. And now let's take a look at the result. We can see that as the bar graph demonstrated on the right of this slide, we got the 3 various fundamental foundation models, and we've got various assessment dimensionalities here. We can see that the robustness of SAA is verified by proposed approach here. We've got the whole process have slightly high cosine similarities, including idea generation, task decomposition, workflow generation, code generation, power diagram, and analysis and classification, self-refinery, and the solution recommendation, plus the material planning process and financial calculation as well. So the whole process, including issue finding to business finance allied optimization, are achievable by using this SAA with overall cosine similarity varied between 0.78 and 0.86. The large-scale base model make better answers, but just slightly higher. So this means that once we got the edge-based system that need to be deployed, we may be able to use a small, medium-sized foundation model as the base here. The agents plus latent space evolution is now proved to help us to make our complex decision chain. As the instance of valve leakage demonstrated on the right of this slide is the real product you are here. And the whole process, as we can see, could be done by SAA through the autonomous way, and human just need to enter their intent. The whole process will be interacted by natural language, and the whole thing is achieved through the hyper-automation way. The data plus knowledge to expand the situation could be done and make it, and could be transparently demonstrated on the website for helping humans do the decision making, and the latent dry run to find the optimal is achievable here. This means that the maintenance efficiency increased based on our new approach. As we can see that the feedback and refinery can be evaluated on the same website as well as the screenshot demonstrated on the 4 o'clock side on the right side of this slide. Now here comes the conclusion. We do believe that SAA available for high-value asset maintenance, especially the wellbores in shale oil field. We do been able to achieve the before failure and efficiency maximum by using this swarm agent-based approach. The human in the loop is now even more efficiency to be allowed in here to dig up more potentials. With currently 600% wellbores being applied, we do now believe that there's a potential product in wellbore operation decision making. It's a replicable and scalable product here, definitely for now. Now, I'm going to end it up here. And finally, I'd like to thank our fund provider, our experts and volunteers recruited and participated in this study. I'm also giving my contact details on the right of this slide. And once again, for all of you, thank you very much.